Okay, so let's think about this now. So we know that when sine is zero, we are dividing by zero, and we can't do this, so it must be that everywhere where sine is zero, we have asymptotes here, and I've drawn them in blue. So now what's going to happen when sine is 1 and cosine is 0, sine at pi over 2 is 1, cosine pi over 2 is 0, so here's where these points go, the 0 points. And you should definitely suspect that these graphs have something in common. They look something alike. I mean, what did we do? We just flipped this upside down, right? So the real question is it going to rise up this way or fall this way? And I'm going to redraw another picture because this one is really getting kind of messy. Okay, so let's think about this again. Let's draw this up. When sine is 0, we cannot have values for this function, so let's draw our asymptotes in. And this one got off a little bit. When is this function going to be 0? Well, this function is going to be 0 when cosine is 0 and sine isn't. We can't have 0 on the bottom ever. When's cosine 0? Cosine 0 at pi over 2, 3 pi over 2. Notice that sine is not 0 at that. It oscillates between 1 and negative 1. So here are our 0 points. Now let's take this and see what it looks like. What is this function value at like pi over 4? Well, at pi over 4, this is going to be 1, right? Because this is going to be cosine pi over 4 divided by sine pi over 4. These are the same. This is 1. So I know that this is a positive 1. I guess I'll just call this 1. It doesn't matter. Also, as sine is going towards 0, cosine is going towards 1. So cosine x is going towards 1. Sine x is going towards 0 as x goes to 0 from the right. Actually, we do this in calculus a lot, and I should start showing you this notation. This notation is great. Basically, without defining a limit, what I'm saying is that as we approach 0 from the right, the reason that plus is there, it says I'm going to 0 from the right. Sine is going to 0, cosine is going to 1. Not only that, the values of sine are going to be positive. The sign, as these will all be positive numbers over here. Why? Because from 0 to pi over 2, actually from 0 to pi, sine is a positive number, right? So this is going to look like this. What's going to happen right here? Well, this is going to be 3 pi over 4, right? 3/4 pi. Well, let's pick 3/4 pi. So cosine of 3/4 pi is going to be what? It's negative 1 over the square root of 2. And we should probably really make sure we talk about this, because this is where knowing the quadrants and what have you are really kind of important. Here's our unit circle. And it's the unit circle because I'm just going to have the radius be 1. Here is 45 degrees as best I can draw it. Oh, yo. Okay. So here's pi over 4. Then we go up 45 more degrees. This is pi over 2. Where is 3/4 pi? Well, it's another fourth added in. And why did I want this picture to be clear here? Remember, 3/4 pi radians is this angle, 3 pi fourths or 3 pi fourths, and Here's the picture we're going to use, though, to draw or to figure out these values. And this is what we need to know. So here, this is the unit circle. That means that the radius is 1. That means that the cosine and the sine are just their coordinate values right here. So this is 1 over the square root of 2, 1 over the square root of 2. That makes cosine and sine come out nice. Well, so if we move over here, what is this? Well, this is positive 1 over the square root of 2. This must be negative 1 over the square root of 2. This is 1 over the square root of 2. So the cosine of this is going to be negative 1 over the square root of 2. Why did I go on so much about all this? That means the sine of this, well, this is the first quadrant and the second quadrant. Sine is still positive in the first and second quadrants. So this is 1 over the square root of 2. This is equal to negative 1. And now that I know that, I'll put negative 1 in here, hopefully it's pretty clear that this does this. And now we know that it's periodic with also period pi. And it looks like this. See, actually, this kind of analysis, one of the things that you get gypped when you put a computer program in or your calculator just shows you a graph is this kind of analysis, figuring out where things are rising and falling, where their zeros are. This has some practical applications just in the ability to think about how to think about things. When you take physics, one of the things about physics that will really become clear and what physicists do better than anybody in the world. I'm a mathematician, but I give a lot of power to physicists. I give a lot of credence to physicists because they use mathematics very well. And what they do is they break down very complicated problems and analyze the pieces of them and then put it back together to try and get a big picture. And this kind of analysis, this reductionism, has given us many, many great insights into how nature and reality seem to be working at this time. So this kind of analysis, although in and of itself you may not ever need to know what this graph looks like, the ability to figure it out by yourself probably is worth having. Okay, so we have a little more time before this particular tape runs out. And let's do a construction, and I'll use this basic picture. Here's x, here's y, here's r, which is x squared plus y squared square root. And this angle is alpha. So the cosine of alpha is x divided by r. The sine of alpha is y divided by r. The tangent of alpha is y divided by x, which is also sine over cosine. Secant alpha is 1 over cosine. That's just this upside down. So this is r divided by x. Cosecant alpha is this over 1, or 1 over this, which is this upside down. This is r over y. And cotangent alpha is just this upside down. This is x over y. These are the 6 trigonometric functions. You're going to be dealing with these all semester, all through this course, and you'll definitely need to know these and their relationships together. Along with, for now, what do we have? Sine squared x plus cosine squared x is equal to 1. We know that tangent squared x plus 1 is equal to secant squared x, and we know that cotangent squared x plus 1 is equal